So the next speaker tonight, Suyash on stage from InfluxData, is a developer advocate, and he was previously working in the US, big data companies, and I've heard that he's a very talented data scientist, but also he can work magic outside of his job as a data scientist, developer by day, magician by night. Magician Suyash is going to be talking about harnessing time series data for MLOps, and on that, and with both a presentation and a live demo. So really excited to see this, and yeah, take it away.
Thank you, Alex, and thank you, the whole team behind MLOps London. It's like a lot of people who make this happen. So let's just give them a round of applause right now. I'm very excited to be here. I've been there coming to this meetup, and so I'm a little bit nervous as well. I moved to UK about 2 years ago. I was working in Bay Area and Silicon Valley before. And since about a year-ish, not even a year, 6 months, I've been at InfluxData. So I'm new to time series world. How many people know what time series is? Time series data. Okay, good. I guess this is the crowd. How many people? Well, the rest, I guess you don't. So I'll introduce the topics. Then in the end, we'll go to the live demo. If you find anything interesting, you can feel free to tweet or post it on X. Mention the companies as well. They would really like it. So let's see, the clicker should turn on. Makes life much easier. There we go. So our agenda is basics of time series. We'll dive into the machine learning side of things, or deep learning, because we're going to talk about LLMs. And we're going to cover 2 use cases: anomaly detection and forecasting, live demo, and then Q&A. And following Q&A, grab me, ask me questions. I'll give you my contact as well. So I assume a lot of people are familiar with DevOps, right? This is MLOps meetup, but if you're doing anything around monitoring and observability, you're familiar with this type of visualization, right? Here we have a graph, something like a dashboard from Grafana, or even our company InfluxData. You can see a little simple graph where you can visualize time series data. Very common use case. Why? Because we want to monitor our systems. Other use cases of time series data are in finance. So how many people work in finance in London? Some, okay. Big industry, right? They make a lot of money. Time series data is critical. I mean, you imagine how, people who are trading stocks, and this value changes like sub-second. All of these stocks, NVIDIA, right? All these things that crashed recently, a lot of people made money as well, right? People do shorting, all kind of thing. And then there are algorithmic trading. But at the heart of that is a ticker that is kind of tracking the movement of the stocks over time. Great case of a data that would stay in something like a time series database. Other examples are IoT. So I brought here Raspberry Pi. I make some demos with IoT as well. A lot of our customers are energy monitoring companies that have plants and big machineries, or in factory floor, or there are many other companies doing smart vehicles and things like that. They're monitoring data from the sensors in real time, and then doing all kind of processing on that. All of that data is a perfect example or a fit for time series data. Then finally, biometrics, right? If you wear something like a real-time monitor for whatever, that is tracking your data over time. Another example of that. IoT, we already covered it. And we're going to dive deeper into these graphs, because this is where we're going to see like how do we do forecasting, which is where basically we are kind of making, you can say, estimation about the future trajectory. Or how do we detect anomalies, like something that shouldn't happen but has happened. Imagine if in a factory floor, a robot arm is doing some kind of operation, but it breaks down. There is nobody there. Everything is automated. It's running 24/7. You want to be notified. So it's critical to track those things. better if you can predict before it happens. So there are two essential like attributes of time series data. One of them is called metrics, which is you can think of a regular interval. So, for example, the temperature here, it's at a regular interval. It is set. It might fluctuate up and down. An event might be if the power goes out and this room becomes really cold. That would in our terminology, we'll call that an event. It's an irregular occurrence of a data at a certain time interval. There are other terminologies and lingo, but I won't go into that today. But I do want to cover just a little bit dive deeper into the use cases. So we talked about DevOps use cases, modeling, application, infrastructure, system, networking, and machine learning use case. There are many use cases. So today we're going to do machine learning on time series data, but there is another use case in MLOps, which one of our customers uses for that, which is telemetry. When you're training these big models, you wanna monitor the performance of the training. You want to monitor like when the model drifts. So you want to do observability on the MLOps system as well. So that is another use case. Of course, hardware IoT we talked about, industrial IoT, those are big use cases. Other attributes are for especially a time series database, because time series data comes in huge chunk, and it comes in real time, it can come in batches, it can come like it. So one of the critical factors is you want to ingest the data, high amounts of data easily and very quickly. And then because the data can pile up, imagine like if we were tracking all the sensors of this whole building, it can become like huge, gigantic data. And database, you're paying for storage, you're paying for compute. So we want to be efficient. So good time series database, it compresses the data, so it's cost effective for you. It is cheaper and it's better for performance. There's another thing called cardinality. You can again think about like different attributes of the data. So if we have sensors here, how many types of sensors they are sending what kind of data. Cardinality problems can explode in a time series use case. Querying. So a lot of these systems, generally big use cases, you want to do real-time monitoring and alerting. So if you have a dashboard that you are looking at and you're looking at your server performance, you want to make sure it's querying in real time and giving you almost real time observability of your system's performance. So at the heart of it is like how fast can you query the data? So it has to query really quickly for you to have real time analytics, right? So a lot of people say, why don't we just throw this in Postgres? It's a very common, popular database, but I guess a lot of you are already familiar with time series database. You're smart enough to know that that is a relational database. You can put, a column, call it a timestamp, and send data and have it timestamped, but it's not optimized for various other reasons, like these reasons we talked about: compression, high ingestion, cardinality, query, big one, really fast. It fails. So like when I give a like beginner time series talk, I talk about like the evolution of database, but I think you already know, because relational database are certain, they have a use case for certain things, like storing transactions or e-commerce records, or for employee and various type of transactions you want to do. Document is another type of database. So in 2025, we use specialized technology, right? So if we want to store like let's say your WhatsApp chat messages or your ChatGPT text, you won't use a relational database. You would use something like a NoSQL database or a document database. If you want to search that, you will use something like a search optimized database like Elastic. Time series database, for that reason, for data that essentially the previous things I covered, all of that, you would use a time series database. That's the most optimal. And the company I happen to work at, InfluxDB, it leads the chart. As for a website, you can go DB Engines, third-party website that does benchmarking on various type of databases. And InfluxDB, it's an open source database, and you can see their benchmark, and it ranks number one in the category. So it's built on top of open standards, modern open standards, something called Apache Data Fusion. This allows you to store data or query data using SQL. Something else we use underlying our database engine is Apache Arrow. This is another open source project, very popular, used or contributed by many companies, which allows to store data in memory, in RAM, so you can quickly access it, right? Because you want to do a real-time query. There is another thing called Apache Parquet, which is a file format that is optimized to compress the data, so you can throw it in an object store like S3, right? So it's cheaper. And then finally, this is the engine. So the use case we won't cover today is like where the data comes from. I'm just going to have the data ready to go. But the data, like for IoT, would come in real time from sensors, or it would come from your system monitoring. Like you would connect that with there is a tool called Telegraph. You can use that, or you can directly use our APIs to ingest or send that data, or write the data, technically speaking, to the InfluxDB. We won't cover that part. Maybe I'll show it in the demo, but we will focus on, so this is where the data store lives, but then we're gonna bring the data out, and we're gonna do various tasks on it, especially related to time series MLOps. So analyzing time series data. Time series data is very interesting, fascinating. I guess you probably are on board on that. There are various operations you can do. So you can detect patterns in this data. So some things like irregular movement, or cyclic patterns, or trends, seasonal variations. Imagine if you are an e-commerce company and you want to forecast sales, you want to forecast like inventory. Okay, what it might look like for this product at this month. Well, you would do something like a forecasting for that. So there are various, if we dive deeper into that, there are various ways to do that, to do analysis on this data. Very common use case is called rolling averages. It's also done in finance and stock market. So you're calculating smoothing the data to capture long-term trend, like 7-day moving average. Or sometimes the data might not look complete. There might be gaps in the data. Especially we see like IoT, sometimes the sensor is offline, or the equipment is offline. It's not sending the data. So we are missing data. How do we deal with that? So there are many, many ways to do that. You can fill the data. You can forward or backward fill the data. You can calculate mean value and use that to fill the data. There are many ways to do that. Rarely you want to remove or drop that data. There are other attributes. Well, the data, the one core element or feature, let's say, of this type of data is the timestamp, right? Which is also like the primary key, which is also like used, where the data is kind of indexed on the time. And then there are granularity. So if the data, again, I like to talk about IoT because I love playing with these things. Let's say there is a very popular use case for InfluxDB is called home automation. Anybody use that? Home automation, it's very popular open source project. You can have like a home monitoring thing, like turning on lights. It's an open source project. And you can even have like a voice assistant like Alexa. So if you have something like that, and it's collecting temperature, and it's collecting what time the light was on, all kind of smart bulbs you have, you can connect to that. Now, in a month, I'm not interested in, the data at every second, right? Now, so you can downsample the data. So I'm not interested in that level of granularity. So I'm interested in, okay, just tell me like this day, what was the average temperature in my room, right? Because it's sending me all the data. So there are various ways to go into the granularity of the data, and then cardinality we talked about, many unique values. So now, as we're diving into the forecasting world, forecasting has been there, like it's very old what should I call, technology, or it's an old technique. It predates like even computers, because people have been forecasting for decades. In programming terms, a popular language called R is very popular. Python, of course, as well, for doing a lot of statistical data, like forecasting. So specifically, I'm talking about forecasting time series data, which is slightly different than normal forecasting word that might be used in machine learning lingo, because we are essentially doing something like this. Let's say we have data for this time frame, and we want to know what it might look like, months ahead, right? Imagine like how scientists like forecast there might be another pandemic or not, right? A lot of calculation goes into that. So there are statistical methods that are involved. So these are older techniques. I'm not going to discount them. They're still useful. Depends on the use case. So something as simple as linear regression, you want to fit the line, predict this, or a random walk algorithm. Or you want to do something called exponential smoothing, where you are giving more weight to the recent data and lesser to the older data. So it's more useful when you want to do something forecasting for a short-term time frame. There is another thing called lagging features, where we are looking past values to predict future, capturing data-based sales temperature. So lagging data is kind of like these, like lags that we are seeing in the data. So those would be the features in our data set. There is a very popular method called ARIMA, which stands for autoregressive moving average. So it's predicting future based on past values, smooths the error to improve prediction using moving average. And then the variation of that is, so this doesn't tell you seasonality like in the data. So there can be seasonality, unique, like data changes based on a particular season in the terms of data. So this model, this technique, it is able to forecast seasonal patterns as well. So there is a whole world around this. If you just look time series analysis, you can read up about that. But like the new hot thing, or the cool thing these days, is using large language models, like with everything, right? Like we were talking before. But again, I'm not discounting it. It's useful depending on various use cases. I try to create a table to compare which techniques. Essentially, this is the most popular one, ARIMA, or we're going to look into something called Prophet. It's a time series machine learning library, came out of Facebook research. And then another one that is based on large language models. So those three, I can think of like different evolutions: deep learning, machine learning, and more classical technique. But talking about large language models, you are probably familiar with the word called tokenization. So the data, the text, right? It gets tokenized, and then it gets stored, and then it gets vectorized, right? So similarly, the data, which is a numerical, which is a time, there are two axes essentially. I mean, there can be multiple cardinality, but there is always a timestamp, right? That is one data. And then let's just say temperature or stock price or whatever, that would be a numeric data, right? Now you can tokenize that as well. So what people have done, researchers, if you read these papers, they've used the same technique, the large transformer models, that architecture, and they're trying to use that for time series data, forecasting time series data. So this is just shows the underlying architecture, how they tokenize the time series data, and then they quantize that so that you can get the discrete values of the data, and then they use that to train and then make predictions. So this is a very complicated chart at the bottom. Just wanted to, I found this in one of the papers, because nice thing was that they put a time horizon and they showed various techniques that have come out. So this is very popular. It came out of IBM, called Lag Llama. It uses the Facebook Llama open source model, and they use lagging features, essentially time series data for that. There are other ones, popular ones, LLM time, There are other one, GPT for time series, very popular, and there are other ones. So essentially, we don't need to go into the detail. This is more the intrinsic detail. If you're a researcher, we can talk about it. But I want to get into the code thing and be mindful of the time as well. So some useful libraries. So this library ADTK is a useful library, more a little bit dated, you can say. Facebook's Prophet library is another time series library. Slightly older, a newer version of that is this one called Neural Prophet. Even the blog I read, written by the Facebook researchers, they said they recommend using this one. It's underneath, it uses this library, but they've added more fancy operations using neural networks. It's actively maintained from researchers at Stanford University. And then this is the one that came out last year. This is much more newer, just a few months ago, or I think last year, and there have been updates if you look on GitHub. So this is called Chronos. It's from AWS Research, and it's using deep learning LLM models. So let's look into some code because we'll make everything come together with that. So first, what I'll do is I have two demos to show you. I will show you how to use Facebook Prophet library. And here I'm doing various things. We'll look at InfluxDB as well, where that comes in. So this is the heart of the program, the main.py file. And so if we look at this, essentially you're importing various libraries, right? And there are some files right here which are helper functions. So I have something called InfluxDB client, which essentially connects to Influx. The main purpose, what we're going to do is we're going to forecast temperature data. We're going to grab data from an open source service that gives you weather data. We're going to get London data for last few months, and we're going to make prediction for upcoming month. Like what, because I'm always curious in London since I've been here, like, do I need to take, like, is it going to rain today or not, right? How many, like, I'm sure locals, like you all, like, you cannot predict that. But hey, maybe, it's a challenge for you guys now, machine learning time series experts soon to be. So this is the program. It's just going to predict the temperature. But, we could make something like, oh, actually, because we can get data of like precipitation. Is it going to rain today or not? So what it does, it grabs data from this website. So they have a free API, right? Because all I'm going to show you is free open source stuff. So this is the JSON response from their API. It tells you basically you provided you coordinate lat long and you ask it like, what do you want to provide in the request? So the current temperature every 2 minutes, wind every 10-minute, wind speed, etc., humidity, and it returns back all of these values to you, right? And essentially, it has a timestamp, right, for all of these. So that's why it's a time series data, because it's changing also weather, right? Weather forecasting is very complicated. There is another thing, might as well cover it right now, that I put it in the appendix. No, it's there. Okay, maybe I'll just mention it. So, and then we'll go back to the code. There are two ways to go about this. So the way I'm going to do it is using something like a batch processing. So we're going to use this data from this API, but it's still past data for last few months. We're not doing this on real time, like right now, like what's going to be the weather in the next 5 minutes. So we're going to do this approach. There is also more real-time machine learning, right? Where you want to do, which is kind of like more useful. Like if you are, imagine like if you are social media TikTok and you want to serve me like a next video or an ad, and you want to know my like habit, my behavior pattern, because you already have a model trained like using my avatar like data. So that's where the real-time machine learning comes in. But right now we're going to do more like a batch processing based machine learning operations. This is a bit more challenging, but let's go back to the code now. So here, this is the code that fetches the data. It's using London's latitude, longitude, and it's gonna get for the last few months. This is the API endpoint, and then here I have process API response. So first, if we look here, we're gonna fetch the weather data, and then I'm gonna print that out, and then we're gonna call process API response. And we're going to store this using pandas data frame library. So we're going to store this pandas data frame object. And then we're going to pass that to InfluxDB. So we're going to pass that to InfluxDB. We're going to store that in InfluxData. And then we're going to do the forecasting on that. Okay, so we got to do a little data massaging here, change it to a different format, store in InfluxDB, send that. So let's just run the code. And if I run it, I have a few like debug logs here. So some things are erroring out, but looks like it got written. And the way I'm writing it is, it's a lot of data, many months of data, like every 2 minutes you saw. So I'm storing all that, and it's already written to InfluxDB. I'm using a way to write to InfluxDB. Also, you can write two ways. So I'm sending it in batches, which is much faster. And let's have a look quickly here. So if we go here, this is what InfluxDB looks like our cloud portal. You can, of course, run InfluxDB on a Pi, our open source version, or your laptop. This is our cloud portal. And here we have very helper like a dashboard or data explorer, where we can write our SQL query. Actually, you don't even have to write the query. So I'll just show you something. So if I just search this is our table. In our lingo, we call it measurement, but it's same as a table. And we write a simple SQL query selecting everything for the last 1 hour. And we want to show that, right? So, and we want to select. Maybe maybe the error was there. Something happened. Let's do this. Let's see. Okay. So looks like the data I pulled, it didn't have the last hour data from the API. I'll change that code. But the data here we got is from, this is 2025, January 26th, at this time, GMT essentially. So it was a few days ago, and that's the data. And we can go back and then it just giving us from like recent data, but it's very granular, the data. Okay, and we can see the data. We can have different ways to look at the data. So whichever you prefer. So we can see it as a table, but we can see it. This graph doesn't make much sense. There you go. That's London weather. So yeah. So wow, one of the day it was really hot, or something is off here. But this is something. Let's visualize this data in a bit. So the data is here. I think I have something in my code. Either it didn't write the data, or this is older data for something else. I'll debug that live demo. But what it also did is so here we also plotted this data. So here we use a few different library. So we use Profit, and we use Matplotlib and other helper libraries to create a visualization. And we use the Tanda data frame object to massage the data, and essentially we pass it. I'll show you. So there's a couple of parameters we're setting true for seasonality, daily seasonality, change point, prior scale 0.01, seasonality, you can read about these. Essentially, we call our model.fit function right here, and we pass the data frame, which has the data and the timestamp. And then what we are doing is there are few data massaging I do, and then I plot this data using Matplotlib. So the data is plotted, and because I was generating a lot, I created a timestamp. So this is the one, and this is the one. What we can see here is this is the historical data that we got from the API. And I'm not plotting the date here, but this would be 26th of December or January. And this is what it's saying the upcoming month might look like. So here we can see that. And yeah, and that is, because it supports, we have turned on few parameters. There are other things that we can do to improve this data. So first of all, this needs data. So this is not using a large language model that doesn't need data to be trained on. So we are providing it our data set for last few months. So if you want to improve the prediction, there are a few other things you can do. You can provide it much longer duration data, because that is not enough. That would be the main thing in this case. And then play around with the other parameters. So yeah, so let's move on to the other example, and then I'll make sure I cover both, and then we can take questions. So this another example, it uses Amazon Chronos library, which is right here. And this, as you can see, it's very active. And it is using the large language model, and it is hosted, it's open source, so it's hosted on Hugging Face. And this is where I got this graphic from. And this is the benchmarking. So they compare like the performance of other time series forecasting libraries. So of course they have highlighted theirs in the blue with the score, and there are other ones not as good. It is quite good actually. There are other benchmarking websites where you can go and have a look as well. So in this example, there are a couple of things we're going to do. So we're going to install this library. So first of all, here I install it, and then I also install InfluxData's Python client library, because we're going to send this data in InfluxDB as well. Here, just because for you going to run this thing, so there is something else you need to do. You need to provide it a token for Hugging Face, because it connects to Hugging Face, because that's where it's hosted. So that's where it's going to make the API call. So you can get a free API key from them, and that's all you need, and that you need to provide that. So we're going to run this cell, and here it's going to do its thing. It takes a little bit to download it. I've already done this before, so it was much faster. Okay, looks like that went through. And here, this is the dummy data. So the dummy data, I'll show you. So here we are going to provide it. We want to do sales forecasting on our sales data. Let's say we are e-commerce company, and or in this example, it's a housing sales data. So here, the data, yeah, this is what the data looks like. So we have a timestamp and we have the amount. And then this is the older data from 2010 to 2012. And as you can see, the data ends somewhere around, actually, it's not in any order right now here, but it is not complete data. So we're again gonna forecast it for the time it doesn't have in the data set. So the way you do it is in this, for here, just to see, we have this GUI, but so there is a lot of code here that is just loading the data and making sure this UI works. So we're gonna run this. And the data, it's here, it lives. So I'm just storing it in this runtime and temporarily the sales CSV file. And it is right here. And this is what it looks like. So we can see it here. And we can also see a visualization, a graphic visualization. So this is really nice in Google Colab that you can not only see in a table format, you can also see, so they have a plotting library baked in and they give you the code for that. So we can see what this data looks like. So so we understand what we are working with, we're gonna plot this. And here, so by default, it is normalizing the data in certain values, but ignore that. So the data, really what it is, it's amount in hundreds of millions of sales, which is the scientific way of plotting it. And here is the timestamp, but this library matplotlib, by default, it has normalized the data to a different value set. But that's okay, because it's still the data we need, and we can still create the models using that. So, but I re-massage the data because what I do here is I write the data back to InfluxDB, and to do that, I use the Python client library, and I just hard coded everything right here because it's much easier to explain and go over it. And I load the CSV file that we have here stored, sales.csv, and I change the data, the year value, to last year. And the data, the table for this would be this one. So once we run this, it ran through. And here we can see this data. This is what the data looks like. This is what the actual data is. So it's basically like these values, sales values at different time frames. So from 2020, I've changed the date. So, but you can see there are some outliers in this data. There are, how many hundreds of millions value was the sales for whatever time period. So this is just essentially making sure debugging everything is loaded correctly and working correctly. So here there are the two columns that I'm going to use, and that's all I need to provide. And then here is where I will create the forecast. And to do this, so there are a couple of things here. So there is, you can ignore the UI stuff that is happening right now. So we are collecting data at every 7th day, essentially, for 1 year duration, the total duration we want to create for 1 year. And we're going to have an interval, which is the days is our unique field, which is the interval, how many days we're collecting it for. And there are other parameters you can read up about there in the documentation. And then this is the UI. And then here we are going to we are going to handling the event handler, and we're gonna, so let's run the forecast. So we are checking the columns exist, and if not, there is some error thing. And again, there's just some error checking here. And this is where we set up our forecasting. So we can run it on GPU, but it's right now it runs on CPU as well. So we'll just run it here, and then it uses PyTorch underneath to do the machine learning tasks, and and then and then we're gonna generate another CSV with the forecasted values. So let's run this. So this takes a little bit. I could have run it on the GPU because that's the runtime, but it ran through because right now it's not a lot of data. And the interval we're looking at 7 for 12 weeks, essentially, the forecast length. So every 7 day. So here, if I call run forecast now, which is somewhere here, it's actually gonna create the forecast. And then we will plot it in this graph. So that went through, and here we are just going to take, because it generated a new file, the sales forecast CSV, and we're going to plot that, and we're going to format it so it's a little bit easier to read. So this is the forecast that it comes up with, and here we can see there are various types of line graph that it generated. So the dark blue one is the historical data, the actual data. And here is where we start to create a forecast. And there was a little gap in our data, which is a problem. So there are ways this library provides you a way to backward fill or forward fill the gap in the data so you don't see something like this. But here it gives you basically the prediction. So it's telling you like at a higher confidence, like this is what the sales numbers may look like. This is the median value, and then this is the lower end of the forecast confidence interval. So this is right now we have done time series forecasting using Chronos. It's much easier to use because it's already trained on huge number of data sets, time series data sets. And it's quite accurate from the benchmarking that they show the scores, especially for like not like a very long-term horizon, but a few months, 6 months. It performs much better than Facebook's Prophet or Neural Prophet or some of the other libraries. Because these things aren't accurate. Like there is nothing, it's a probabilistic model. So it's giving you the interval. So I also have the file which has the actual data for all these months. So we're gonna compare that now. So I will load that. So which is the sales actual data that earlier we didn't have because we wanted to create a forecast. And here we're going to overlap it, and we're gonna create another chart, and we're gonna see what the prediction looks like compared to the actual data. Sales actual load date column. This would be the sales column. Select that. And let's run this again. And here is where we can see this is what the actual and the forecasted value looks like. So the actual value is The actual value is here. It is quite off. So there's something wrong here. So the prediction is off. So this is the actual value. I need to check the data as well because there's something here. There's something gone wrong with this. I think I might have loaded a wrong file or something. Because when I was testing it, because it's a sample data set, it actually matched it. But the black line is the actual value, and then the purple line and the different intervals are what the forecast is. And then we have one more graph here or chart, which basically, which basically tells you how much off it is. So right now, what it's doing is basically it has a high variance. So what would be like, let's say if it is saying because it's saying 0 right now, it doesn't make sense. Let's say if the actual value was 2 million sales and we were getting the median forecast was much higher, so we would have like a higher variance or lower variance, like how off we are, the actual value. So that's what this chart does. So that's that. And yeah, and I hope you learned something. You learn about what time series data is. How do you analyze it? What are the various libraries you can play with that? There's a lot to learn. This is, there's a whole like a semester class on this, but we covered the high level. And if you're interested, there are some links here. I would put a link to both the Python project and the notebook on my GitHub, and you can play with that. But there are some other helpful links if you want to read more about it or just play with the library. This is a really good book on machine learning engineering as well. You can also come to InfluxDB. We have a university where we have a lot of free courses, video tutorials, or find us on Slack. I hang out there. And if you want to check out InfluxData, you can download our new version 3, 4, we call it. It's an open source one that came out recently. It's an alpha release right now, but you're welcome to play with that, or on the cloud. You can try it. It doesn't cost anything. Without using a credit card, you can play with it. So yeah, if you have any questions, take it now.
We've got time for a couple of questions. Yeah, perfect.
Hi, Suyash. This was really nice knowing about time series, a special database for it. So I understand. I'm myself from data product management. So I understand it's meant for time series data, and it's probably even simple to use. But if you could also highlight, specific value propositions wherein so it's a special database for time series data, right? But I also have some other databases in place already in my product or in my organization. Now taking this new database and using it, so are there any real strong things that they are pain points that they are solving, that Influx is solving, which other databases might not help? So if you could highlight.
Yeah. Anytime you want to deal with time, like basically the use cases are very common use cases is real-time monitoring. If you are like because if we think from a business use case, like technology wise, anything, if you want to store anything with time, ideally you would use a time series database. But if you step back, if you're a product manager, you talk to business users, if you are solving a business use case like real-time monitoring, real-time analytics, or a lot of time data, you want to store it for cheap, like for archiving reasons. A lot of like IoT people do that. Like they want to have data for various reasons, just archived, compliance, whatever. So they use InfluxDB. If you want to do time series machine learning, you need the data in a database. You would use a time series database for that. So that's where the data will be. And there are various ways you can export, like CSV file from there, or you can use something called Apache. What's it called? I forget the name of the open source project, that Iceberg, Apache Iceberg project, that allows data to go into a data lake, where from there you can then take the data, train ML model. So there are many use cases. I mean, first slide I talked about, high ingestion, high cardinality. If the data is that type of attribute, if there is time sensitive data you need to store, that's where time series database is useful. But we play with other database. So companies, they use us, but they use Postgres or MySQL or Oracle for other purpose, like this event, like I want to track like how many attendees came, and like Meetup, right? Meetup has a relational database. But if they were doing something with time, like then they would be better off if they would have like more like a real-time operation. Like a DevOps use case is a common one.
Just last. So also, could I find some resources for comparison of Influx with other database solutions
Yeah,
on somewhere on the
yeah. So there is a website called DB Engines. That's like more technical performance. But if you want to feature-wise, I'll help you. I can point you to various places where you can see the value of which.
We'll take one more quick question, and if anyone else wants to chat to Suyash after the official session is closed, you'll be sticking around for a bit.
I also have stickers. If you like, we have like cool stickers for your laptop, or people like to take it for their children. You're welcome to grab them as well. Yes.
Thank you very much for your insights and talk today about the time series database. You just made a reference to Oracle. Oracle in its heydays was a relational system. The latest incarnation of Oracle now is a converged system incorporating time series database. In fact, on installation, it prompts you on what you want to do.
Sorry, can you repeat the question again?
No, you made a reference in your last answer.
To Oracle, yeah.
You made a reference to Oracle in its heydays as a relational system. That's now changed, actually. Oracle is a converged database system that incorporates everything.
I see. Yeah. Oh, I used to work at Oracle. Yeah, no, for sure. What I'm showing. It's like a simplified version. These companies these days, they are, if you read their marketing, they're gonna say you can store all kind of data in our database. But if you think about it, how the database schema is created, if it is and what it affords, what it allows, what kind of operations. And then ideally the best thing, like what I also tell our users, to download all the companies. I guess these days most of them have open source version. Play with it, see your use case, see like query performance or cost of operation, storage, compute. Like how does that really look like on a dummy data set? How easy it is to work with that database. Various other things, like if it's a managed service, like many things come into play. Security, data, retention data, like duplication, all these things. And then you see if that meets your use case. But it is at the heart like a relational database. They say you can store this and this and this in there. But the way companies these days, I noticed, like if you're just starting out, you can maybe get away. But as you start to scale and you want to make your operations more efficient, then you look for things that can cut the time or save operational time, cost, makes things more efficient. Then companies look for specialized solutions. So that's just been my experience.
Well, so many questions and super interesting talk and demo. I learned a lot, lots of things to take away. I'm going to be predicting the future price of Bitcoin and making millions of dollars. So it's going to be exciting. And yeah, thanks a lot, Suyash. Great demos. And thank you everyone for joining us this evening. Thanks to Ben. Fantastic talk about the small language models from Microsoft. Do reach out to Ben. And special thanks to Alex B. Selden, who's been an organizer as well as the meetup, and Tanu. Yeah, we'll be hosting our next one in April. So yeah, look out for the announcements. We are always looking for speakers, so reach out. Again, marketing@selden.io. If you want to reach me directly, feel free to email alex@selden.io. Yeah, we'll stop there. Thanks to everyone online. Feel free to hang out for a little bit. before heading off. So yeah.
Can I mention one thing?
Yeah,
quickly?
sure.
Thank you. So I also created a meetup group in London around data, AI, and robotics because I've been playing with IoT. If you're interested or you're playing with that, welcome to join. If you search London RAD robotics AI data, you'll find the meetup, and always looking for speakers and space, just like any other meetup in London. So